Good morning. Welcome to my channel. Those who are not watching the previous video can now watch this video. Those who are not understand the previous topic, I put the lesson name in the description box. You see the description and then you watch the video. ಯಾರು ಹಿಂದಿನ ವಿಡಿಯೋನ ವಾಚ್ ಮಾಡಿಲ್ವೋ ಇವತ್ತು ಈ ವಿಡಿಯೋನ ವಾಚ್ ಮಾಡ್ಬೋದು. ಯಾಕೆ ಹಿಂದಿನ ವಿಡಿಯೋ ಅರ್ಥವಾಗಿಲ್ವೋ ಆ ಟಾಪಿಕ್ನ ನಾನು ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸಲ್ಲಿ ಹಾಕಿರ್ತೀನಿ. ಆ ಚಾಪ್ಟರ್ ಪ್ರಕಾರ ನೀವು ಆ ವಿಡಿಯೋನ ವಾಚ್ ಮಾಡ್ಬೋದು. ಸೊ once again I welcome to my channel. So in previous class what we have learned about the trigonometric functions. Trigonometric functions is a function in which we measure the sides and angles of a right angle triangle using some of the trigonometric ratios like a sin theta, cos theta, tan theta, cosecant theta, secant theta and the cot theta. Then after that we have quadrangles. What is a quadrangle? Quadrangle is that all the angles which are integral multiples of pi by 2. See, all the angles which are integral multiples of pi by 2 are called quadrangles. Quadrangles ಅಂದ್ರೆ ಏನು? All the angles, ಎಲ್ಲ angle which are multiples of pi by 2. pi by 2 multiples ಇದ್ರೆ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Quadrangles ಅಂತ ಕರಿತೀವಿ. ಅಂದರೆ all the angles which are integral multiples of pi by 2 are called quadrangle. Then after that we have problems on the quadrangle function. Problems. If cosecant A is equal to x by y, then find the value of cot A. If cosecant A is equal to x by y, then find the value of cot A. ಅಂದರೆ cosecant A ನ ನಾವು ಬೆಲೆ ಕೊಟ್ಟಿದ್ದೀವಿ, cot A ಬೆಲೆನ ನೀವು ಕಂಡುಹಿಡಬೇಕು. We know that cot square A is equal to cosecant square A minus 1. Therefore, x by y whole square minus 1 that is equal to x square by y square minus 1 that is equal to x square minus y square by y square. Therefore, cot A is equal to plus or minus root x square minus y square by y. Once again I will explain in Kannada. See, ನಮಗೆ ಗೊತ್ತಿದೆ cot square A ಅಂದ್ರೆ ಏನು? ಅದಕ್ಕೆ ಫಾರ್ಮುಲಾ cot square A ಫಾರ್ಮುಲಾ cosecant square A minus 1. cosecant square A ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ x by y whole square minus 1 that is equal to x square by y square minus 1 that is equal to x square minus y square by y square. That implies cot A is equal to root of x square minus y square by y. This is the value of the cot A. Then we move to the second problem. Tan square theta minus sin square theta is equal to tan square theta into sin square theta. Here we have tan square theta minus sin square theta as LHS and tan square theta into sin square theta is RHS. First we have to take LHS. Tan square theta minus sin square theta. We know that tan square theta is sin square theta by sin theta by cos theta whole square minus sin square theta. That is equal to sin square theta by cos square theta minus sin square theta. Sin square theta minus sin square theta cos square theta by cos square theta. That is equal to sin square theta is taken as common. We left with 1 minus cos square theta by cos square theta. We know that 1 minus cos square theta is sin square theta. Then sin square theta into sin square theta by cos square theta. That is sin square theta into sin square theta by cos square theta, that is equal to sin square theta by cos square theta is tan square theta into sin square theta, that is we call it as RHS. We arrive at the RHS. Welcome to the third problem. See it carefully. A cos theta plus B sin theta is equal to x, and A sin theta minus B cos theta is equal to y. Then prove that A square plus B square is equal to x square plus y square. See, once again I read the problem. A cos theta plus B sin theta is equal to x, and A sin theta minus B cos theta is equal to y. Prove that A square plus B square is equal to x square plus y square. And then we have A cos theta plus B sin theta whole square plus A sin theta minus B cos theta whole square. After squaring we get A square plus B square, that is equal to A square plus 2AB plus B square. Like that we have to expand this. A square cos square theta plus B square sin square theta plus 2AB sin theta cos theta. And in the same way, A square sin square theta plus B square cos square theta minus 2AB sin theta cos theta. 2AB sin theta cos theta plus 2AB sin theta cos theta minus 2AB sin theta cos theta get cancelled. Here you are left with A square sin square theta plus A square cos square theta plus B square cos square theta plus B square sin square theta. Then taking on one side, if you take A common, A square common, sin square theta plus cos square theta. If you take B square common, cos square theta plus sin square theta. Then we know the identity. Sin square theta plus cos square theta is equal to 1. Write this. Sin square theta plus cos square theta is equal to 1. Sin square theta plus cos square theta is equal to 1. Substituting that, A square into 1 plus B square into 1. Therefore, A square into 1 is A, B square into 1 is B. Therefore, A square plus B square. We have arrived at the answer. Welcome to the fourth problem. Then prove that 1 plus tan square A by 1 plus cot square A is equal to 1 minus tan square A by 1 minus cot square A is equal to tan square A. Here we have two problems. First problem is 1 plus tan square A by 1 plus cot square A is equal to tan square A. That is one problem. And 1 minus tan square A by 1 minus cot square A is equal to tan square A. That is two problem. We have to show that for these two problems there is only one answer, that is tan square A. First we take the first problem. 1 plus tan square A by 1 plus cot square A. We know that tan A is equal to sin A by cos A. That is equal to 1 plus sin square A by cos square A whole over 1 plus for cot A cos A by sin A. Therefore, that is equal to 1 plus cos square A by sin square A. That is equal to, if you take cos square as the LCM, we left with cos square A plus sin square A over cos square A whole over, if you take sin square A as LCM, sin square A plus cos square A over sin square A. Here cos square A plus sin square A over by cos square A into sin square A over sin square A plus cos square A. because denominator of the denominator goes to the numerator. Therefore, sin square a will go to the numerator. Cos square a, sin square a get cancelled. You left with sin square a by cos square a, that is equal to tan square a. That is a past first problem. So we proved 1 plus cot tan square a over 1 plus cot square a is equal to tan square a. Right. Then so part second of the fourth problem, that is that 1 minus tan square a by 1 minus cot square a is equal to tan square a. We have to take LHS. 1 minus tan square a by 1 minus cot square a, that is equal to 1 minus sin a by cos a whole square by 1 minus cos a by sin a whole square. That is, if you take a cos square a as a LCM, you left with cos a minus sin a whole square, and if you take sin a as LCM, sin a minus cos a whole square by sin square a. Then after expanding a minus b whole square, a square minus b, a square plus b square minus 2ab. Like that, cos square a plus sin square a minus 2 sin a cos a over cos square a. Here sin square a plus cos square a minus 2 sin a cos a over sin square a. 2 sin a cos a and 2 sin a cos a get cancelled. You know that identity, cos square a plus sin square a is equal to 1. Therefore, 1 by cos square a into sin square a by 1, that is equal to tan square a. This is the problem. Therefore, that is RH.